Okay, good morning, class. Today we're going to begin the Unit 5 work, starting with simplifying roots and radical expressions. Now, this page 1, it has a lot of notes. I'm not going to read these notes. I'm actually just going to jump to page 2, where our work begins, and just get right into it. Okay, simplify each root. Now, with A, the negative of the square root of 81. Well, the square root of 81 is 9. We bring the negative down, so the square root of negative 9. B, the cubed root of negative 64. Punch that in on your calculator, you'll get negative 4, because negative 4 cubed does give you negative 64. Now, the square root of negative 81. I would simplify that as the square root of 81 times the square root of negative 1. Square root of 81 is 9. The square root of negative 1 is I, which is imaginary. Since we get an imaginary solution, we actually have no solution. Because if you punch that in on your calculator, well, let's just do it and let's see what we get. Okay, let's punch in the square root of negative 81. Error, a non-real answer. So that's why if you get imaginary, it's no solution. Okay? Let's move on. Okay, class, let's look at question D. Fourth root of negative 16. If we were to break this down, you could break it down as the fourth root of 16 times the fourth root of negative 1. And you would get the fourth root of 16 is 2. Fourth root of negative 1. There's a negative solution, which is an imaginary. Since we get an imaginary number here, we get no solution. Let me show you on calculator why this would be no solution. Okay, so if we put in the fourth root, oops, let me clear that. Okay, we want to do fourth root of negative 16, and we hit enter. Non-real answer. No solution. Okay, let's move on. The square root of 0.25 is 0.5. You can punch that into your calculator and get that. Matter of fact, all of these you can punch into your calculator and pretty much get. The fifth root of negative 32 is negative 2, because negative 2 to the fifth power is negative 32. The negative of the cubed root of negative 8. Well, the cube root of negative 8 is negative 2, but then we have the negative, so they want the negative of negative 2, which is positive 2. Then for h, we have the fourth root of 0.0016. Punch that into your calculator, you'll get 0.2. Very simple. Let us proceed forth. Okay, simplifying radical expressions. So they want us to simplify the square root of 81x to the fourth. Well, 81, that could be simplified as 9 squared. And x to the fourth could be x squared to the second power. Because 9 squared would give you 81, and x squared to the second power would give you x to the fourth. And then if we're taking the square root of each of these, well, the square root of 9 squared is just 9. The square root of x squared is just x squared. So 9x squared would be the simplification of this particular radical. Let's move forward. Simplify each radical expression. Okay. A, the square root of 25x to the sixth y to the 0. Well, the square root of 25 is 5. The square root of x to the 6 is x to the 6 over 2, which is just x cubed. Y to the 0 is 1. So it's just 5x cubed. Anything to the 0 is 1. Remember that from the properties of exponents. Let's move to B. The cubed root of 343 x to the 9th y to the 12th over 8. We could break this into the cubed root of 343 x to the 9th y to the 12th over the cubed root of 8. Now let's take care of the numerator. Cube root of 343 is 7. Cube root of x to the 9th is x cubed. Cube root of y to the 12th is y to the 4th. That's our numerator. Cube root of 8 is 2. That's our denominator. Boom. We're done. Let's move on to C. The negative of the fourth root of 625, a to the 8th, b to the 16th, over 16. Again, I would break this into 2. So this would be the fourth root of 625, a to the 8th, b to the 16th, over the fourth root of 16. Then I'll just break it down. Fourth root of 625 is just 5. Fourth root of a to the 8th is a to the 8 over 4, which is just a squared. Fourth root of b to the 16, the b to the 16 over 4, which is just b to the 4th. Fourth root of 16 is 2. So there's our numerator, there's our denominator, and don't forget to bring your negative down, so there's a negative in front of this solution. So negative 5a squared b to the 4th over 2. Let's go to D. The cubed root of negative 64, x to the 6y cubed. Well, the cubed root of negative 64 is negative 4. The cubed root of x to the 6th is x squared. The cubed root of y cubed is just y. Hopefully I'm not going too fast for any of you. If I am, just simply rewind this video and look at these here, and hopefully these won't be too challenging for you. All right, so now we're going to get into a little bit of challenging work, simplifying radical expressions. All right, let's start with A. The square root of 50n to the 6th, y to the 5th. What I would do is break this into 2 radicals. Everything that's a perfect square will be under my first radical. Everything that's not a perfect square will be under my second radical. So the square root of 50, I would break down as the square root of 25 times the square root of 2, because 25 times 2 multiplies to 50, and 25 is a perfect square. N to the 6th is also a perfect square. Remember, any even exponent is a perfect square. Y to the 5th is not a perfect square, but y to the 4th is. I can take 4 of these out. I'll place the remaining y under this radical. Now I'll simplify this first radical. Square root of 25 is 5. Square root of n to the 6th is n cubed. Square root of and y to the 4th is y squared. Oh, I forgot to write the 2 there. So that's y squared. It's 5n cubed y squared times the square root of 2y. Okay, let's look at B. The cubed root of 40x cubed n to the 5th. Again, breaking it into 2 radicals. Everything that's a perfect cube under my first radical. Everything that's not a perfect cube under my second radical. So I would break down the cube root of 40 as the cube root of 8 times the cube root of 5, because 8 times 5 is 40, and 8 is a perfect cube. X cubed is a perfect cube. That goes under my first radical. N to the 5th isn't, but n cubed is a perfect cube, and then I'll place the remaining 2, the n squared, under this radical. Now I'll simplify. The cube root of 8 is 2, cube root of x cubed is x, cube root of n cubed is n, and then just bring down the cube root of 5n squared. All right, let's move to C. The cube root of negative 56 y cubed z 7th. Again, breaking into 2 radicals. Everything that's a perfect cube under the first radical. Everything not a perfect cube under my second radical. So the negative 56 I would break down as the cube root of negative 8 times the cube root of 7. Y cubed is a perfect cube. That goes under my first radical. Z to the 7th is not a perfect cube, but z to the 6th is, and I would place the remaining z under my second radical. Now I'm going to simplify this first radical. Cube root of negative 8 is negative 2. Cube root of y cubed is y. Cube root of z to the 6th is z squared. Then I bring down my cube root 7z. All right. Let's go to D. The square root of 98, x squared, y to the 11th, z to the 9th. Again, breaking it into 2 radicals. Everything that's a perfect square under my first radical. Everything not a perfect square under my second radical. So the square root of 98 I would break down as the square root of 49 times the square root of 2. X squared is a perfect square. That goes under my first radical. Y to the 11th is not a perfect square, but y to the 10th is. I'll place the remaining y here. Z to the 9th is not a perfect square, but z to the 8th is, and I place the remaining z here. So now I simplify the first radical. Square root of 49 is 7. Square root of x squared is x. Square root of y to the 10th is y to the 5th. Square root of z to the 8th is z to the 4th. Then I bring down my square root of 2yz. Okay, on to e. Okay, let's continue on. All right, so the cube root of negative 128, a to the 16th, b cubed c to the 10th. I will again break this into two radicals, everything a perfect cube under my first radical, everything not a perfect cube under my second radical. So I would break this as the cube 120, the negative 128. I will break that as the cube root of negative 64 times the cube root of 2, because negative 64 times 2 does give me negative 128, and negative 64 is a perfect cube. A to the 16th is not a perfect cube, but a to the 15th is, and I will put the remaining a under the second radical. B cubed is a perfect cube. I will place this under my first radical. C to the 10th is not a perfect cube, but C to the 9th is. I place the remaining C under my second radical. Now I simplify all of this. The cube root of negative 64 is negative 4. The cube root of a to the 15th is a to the 15 over 3, which is a to the 5th. The cube root of b cubed is just b. The cube root of c to the 9th is c to the 9 over 3, or just c cubed. Then I bring down my cubed root of 2ac. Now let's go over to f. The fourth root of 64, x to the 6th, y to the 9th, z to the 13th. Again, I'm going to split it into two radicals. Everything that's a perfect fourth root under my first radical. Everything not a perfect fourth root under my second radical. So with the fourth root of 64, I would break that down as the fourth root of 16 times the fourth root of 4, because 16 times 4 is 64. 16 is a perfect fourth. X to the 6th is not a perfect fourth, but x to the 4th is. I put the remaining x squared under my second radical. Y to the 9th not a perfect fourth, but y to the 8th is. I place the remaining y under my second radical. Z to the 13th is not a perfect fourth, but z to the 12th is. Replace the remaining z under my second radical. Simplifying my first radical, fourth root of 16 is 2. Fourth root of x to the 4th is x. Fourth root of y to the 8th is y squared. Fourth root of z to the 12th is z cubed. Then I just bring down my fourth root of 4x squared y squared. Right, let us move on. There is also another way that you will see radical expressions written. It's a bit tricky because there's no radical. Basically, this is just exponent form, and this is exponent form because our exponent is our power here. Now, this is exponent form, x to the a over b, which is equal to the bth root of x to the a. This is radical form because there is a radical sign here. If you wish to convert from exponent form to radical form, whatever your denominator is in your exponent, that becomes your index in the radical form. So you would just simply take that b, or whatever your denominator is, make it your index, and then x to the a. Let's just practice with this. Now, 15 to the 1/3, the denominator of 3 will become our exponent, our index. So 15 to the 1/3 will be the cube root of 15 to the 1, or just 15. So 15 to the 1/3 equals the cube root of 15, switching the denominator over to our index. Let's look here. 8 to the 2/3, taking that denominator, making it our index. 8 to the 2/3 becomes the cube root of 8 squared. Again, our denominator becomes our index. That's all we're doing. Let's look here. 3x to the 2/5, you take the 5, that's the denominator, that becomes your index. So this is the 5th root of 3x squared. Then again here, with 4a squared to the 1/2, the denominator of 2 becomes our index. 2 is already understood, so I don't have to write it, so it's just the square root of 4a squared. All right, now we're going to go the other way. This was going from the exponent to radical. Now we're going to go from radical to exponent. So now the fourth root of 7, this index of 4 becomes our denominator. So now that's just 7 to the 1/4. Here, the The fifth root of x squared, our index of 5 becomes our denominator. This is just x to the 2/5. Here, the fourth root of 3x squared, our 4 becomes our denominator. So this is just 3 to the 1/4 times x to the 2/4, and x to the 2/4 will just simplify to be 1/2. Here, the square root of 10 to the BC, again, our denominator is 2, so this is just 10 to the 1/2, b to the 1/2, c to the 1/2. Okay, so hopefully you were able to pick up on this, and if you have any questions, or I suggest that you watch it again if you were confused by anything I said, or just ask me questions in class. All right, so that concludes this video. Everybody have a good day. I'll see you in the next video.